derivatives. If I told you if you had to find the second derivative, you had to find the first derivative, then find the second derivative off of it, then the third derivative off of that. So you basically, if you need the fifth derivative, you also need the first, second, third, and fourth. Okay? So to find the second one, there's just no fast way. You have to find the first, then the second from it. Okay? So we're going to use implicit differentiation to find y prime first, then y double prime. Okay. So we have, every day, I do this every day. Okay. Y squared minus x squared equals 5. The first step is to rewrite the equation. We've been trying to tell you guys earlier. And by we, I don't know. So, y squared minus x squared equals 5. How do I do the derivative of y squared? Y. 2y. Then what? dy over dx. Could I go y prime? I have to go y prime because it's asking me for y prime, not dy over dx, right? You have to do the notation that they ask you. I don't know why I wrote the y's differently, but I did. And then minus 2x equals 0. You'll have to stop yourself from writing 5. I do it all the time too. Eric has realized it is going to be a strong issue for him. All right. So we're going to move that 2x over. 2y prime equals 2x. By adding it over, divide by 2y. And y prime equals x over y. Now with implicit, you actually need to do the derivative of that to get y double prime. True. You're also going to need to use your y prime. So we have y prime equals x over y. What am I going to have to do? Quotient rule. So what's the derivative of y prime?
Y prime prime.
Y prime prime. Okay? You just added the two.
We got y quotation.
So now we're going to do g
I got it.
f prime minus f u prime over y squared. We just did product rule, right? F g prime minus g f prime. What is what?
Where did the y prime come from?
Because G prime is
G prime is 1 y prime.
the 1 G y over dx is 1.
Okay. In the first derivative, if you look at the first derivative, I did have a y prime in it, correct?
Here,
But then I just isolated from y prime and I had the first derivative. We agree?
here.
The second derivative, can I isolate y prime? If I isolate y prime, I'm getting the first derivative and I'll have a y double prime on the other side. Is that what I want? No. But it can't have a y prime in it. But if you look at the previous step, the previous one said y prime equals what?
Oh,
X over y. So can I not just, for the second derivative implicit, and it's only for implicit do I have to do this.
so smart.
I'm going to take that y prime, rip it off my board, tuck it across the room, and replace it with x over y, because I know that y prime is x over y. Do we agree? So, y double prime equals y minus x, x over y, y squared, which is a lovely answer. It won't be the one in your book. We have y minus x squared over y squared. They're never going to have a partial fraction in the numerator. So remember, we just did this on the board when we were practicing. If I wanted to pull a half out, when I took a half out of the one with a half, it went away. But when I took a half out of the one without a half, I actually multiplied by 2. We agree? So instead of taking out a half, I'm going to take out a 1 over y. So I'm going to take a 1 over y out. When I do y, when I take it as DCF, it's division, correct? So what's y divided by 1 over y? Y times y, so I get y squared. Minus, I take a 1 over y out of x squared y, and I get an x squared over y cubed. Where can this y now go? So my answer is actually going to be y squared minus x squared.
I think you skipped.
I have no idea what you're talking about. Y cubed. Perfect. Great. Everything's awesome. Everything is awesome. Everything is cool. Yep.
Y squared minus x squared equals 5, but you're putting numerator, or is that not allowed?
Y squared minus x squared equals 5.
Or the original equation.
Yeah, you absolutely can. So you could, don't ask this and it's true. The answer could be 5 over y cubed. Where did the 5 come from? The original equation. The original equation said y squared minus x squared equals 5.
Jonah, you're so smart.
You're matching the answers. That was really nice. Bucket filling. See that? See how you should bucket fill, Sam?
Yeah.
Go to, I'm on a racer. Go to your book and quickly do this question. Go